Okay. For the second part, when you have a rational expression that is a monomial on top, which is a collection of numerical terms like 5, along with variables like x and y on top, and a monomial on the bottom, again, the way we're going to do this is separate it into its greatest common factors. Now, it's a little bit more complex here. The GCF of 5 and 20 is definitely 5 for each of them, because it's 5 times 1 and 5 times 4. And that's pretty simple. But what's the greatest common factor of the x's? What's the largest value of x that both x to the fourth and x squared possess? They both have x squared in them, not x to the fourth. So if I put x squared here and here, I've used up all the x's down there. But if I put x squared here, I still have another x squared up top. For the y values, the greatest common factor of y to the third and y to the eighth is y to the third. So you need to have y to the third in both places. If I put y to the third up here, I've used up all the y's on the top, but there are 5 extra instances of y's down here. Now, if I make it a little bit clearer down here, the x's, if I had 4 of them on top, it'd be like that, and 2 x's on the bottom. We can see that they do have 2 different instances of x's in common. That's why the x squared is the greatest common factor for both pieces. And we can see that there are 2 extra x's left over on top. As for the y, it's going to be a little bit more drawn out here. They have 3 y's in common, 3 instances of y in common. That's why y to the third is the greatest common factor. And 5 more down here that are left over. So you cross out all factors that are common amongst your term. What you're left with is, on top you have a 1 and an x squared. On the bottom you have a 4 and a y to the fifth. And that's the reduced form of your rational expression. But again, when you have letters on the bottom of your question, you have to account for things where they're undefined. So you just take the bottom and you set it equal to 0. Now, to solve these things with 2 different variables when you have a monomial on the bottom is a little bit trickier. So the key thing here I'm going to tell you real fast, if you have a monomial bottom, and again, monomial means there are no pluses or minuses anywhere in between here, you just take each letter independently and set it equal to 0. So x would be 0 here after taking the square root. If I take the 8th root here, it's really simple. It's just going to be y is 0. So those 2 values, x can never be 0 and y can never be 0. And why is that? It's really simple. If I put a 0 here for x and squared it, it'd be worth 0. And no matter what I did with 20 and the y to the 8th, 0 times 20 is 0. 0 times whatever y to the 8th is would also be 0. And thus the whole bottom would be worth 0, and we can't have that. Same holds true if I put 0 in for y. 0 to the 8th would be worth 0, and then whatever it was times this or that would still yield a total overall bottom value of 0, and we can't have that either. So real simple up here, doing this one here, another example. The GCF of my x's, they both have x to the third in them, with 2 extra x's on top. The y's have y squared in common, with 1 extra y on top. 1 is the power up there, even though we don't write it as a 1. The maximum amount of z's that are present in both of them are 1. But there are 2 extra z's on the bottom. And to cancel out all things that match, would leave an answer of x squared y on top and simply z squared on the bottom. And the common mistake here is to say that z can't be equal to 0 only. But remember, my original problem had x's, y's, and z's. Each of them can't be 0 because any one of them, if they were 0, would make the whole bottom worth 0, and we can't have that.